Hello, students, and welcome to May 3rd already. We'll start with our do now. I'd like you to respond to the prompt about showing your values. So it's one thing to have them, but what behaviors, what things can we do to show those values? Sorry about that, my computer's just waking up. Our objective today will be to begin working with quadratics. It's an exciting chapter in algebra. And our essential question, what is the standard form of a quadratic? What is the axis of symmetry? And what is a vertex? So we talked about a few of these in class on Thursday. So we're just going to continue with that work. Our assignment will be to complete the do now, the 2 work pages, the exit ticket, and also, if you are at home, submit your work on Teams. If you are in person, show me that you're working in class. For homework, I'd like you to do homework 1, Introduction to Quadratics. So I have an important announcement about Wednesday. So Wednesday is SBAC testing for distance learners only. Only those people who are listed in PowerSchool as DL. You cannot stay home if you're AB and just think that you'll get on and take the SBAC. There are only 4 people in my second period class and about 5 people, maybe less, in my 5th period class that are listed as DL. And if you ask me who they are, I will tell you in class. We'll talk about that. But you can't just stay home, sign into the meeting, and think that you'll take the SBAC. What you will do is you will not sign into a meeting, but there will be an assignment for you on Wednesday. So on Wednesday, you have an assignment that you have to complete and upload into Teams, and that will be everybody because everybody is distance on Wednesday. No meeting, but just complete the assignment. Very important. If you're a distance learner, then we will be doing the SBAC and you can complete the assignment at another time. All right, so we'll come back to our exit ticket. We do have a do now. For each value in the left column, describe an example or an action or behavior that shows that value. So describe something to show generosity, helpfulness, and honesty. And I'd love for you to take a minute and fill those out now. So let's get started with our lesson. The standard form of a quadratic is y equals ax squared plus bx plus c. C is a constant. A and b are coefficients. So when you graph a quadratic, the equation creates a U-shaped curve called a parabola. And I'm sorry we don't have graphing calculators in front of us right now, but if we use Desmos, so that's what I'd like you to do. And graph these, and what you will see is that you have the first equation, y equals x squared plus 2x minus 5, will look approximately like this, with the axis of symmetry here. And the second equation, y equals negative x squared plus 3x plus 7, will look like this, with the axis of symmetry to the right of the y-axis. Now, if this a value, so in this case, in the case of the first quadratic, a equals 1. In the case of the second quadratic, a equals negative 1. So if a is positive, the parabola opens up, upward facing, like a smile. If a is negative, the parabola opens downward or down, like a frown, down like a frown. So look for that a value, and you can tell even before you graph it which direction that parabola will open up. Now, the vertical line that divides the parabola into 2 equal parts is the axis of symmetry. So the axis of symmetry is the vertical line that divides the parabola into 2 equal parts. So we also have a formula for finding the axis of symmetry, which is x equals negative b divided by 2 times a. Be very careful with the negative sign. Okay, be very careful with that. Now, the vertex is the turning point of the parabola. So now that vertex, so if you have a parabola like this, an upward facing parabola, you can have a vertex like that, or if you have a downward facing parabola, there's your vertex. So when the vertex is at its lowest point, like the first example on the left, the vertex is called a minimum. When the vertex is at its highest point, like in the second quadratic I drew there, then that vertex is called a maximum. So first thing we're going to do is find the axis of symmetry and the vertex and just do a quick sketch of the parabola. So we have y equals x squared plus 8x plus 15. So we're going to find the axis of symmetry. So x equals negative b divided by 2 times the quantity of a. So x equals negative 8 times 2 times 1 divided by 2 times 1, which equals negative 8 divided by 2, which equals negative 4. So the axis of symmetry for this first one is negative 4. Now we need to find the vertex by substituting the axis of symmetry into our x values here and evaluating what y equals. So y equals, careful with your negative signs, negative 4 squared plus 8 times negative 4 plus 15. Okay, and when we evaluate that, we have 16 minus 32 plus 15, which equals negative 1. So the vertex will be negative 4 is our x value, negative 1 is our y value. And just generally, we're going to sketch this in, and let me change my color. So let's see, negative 4, negative 1, approximately like this. And there's our axis of symmetry. So the vertex, negative 4, negative 1, and our axis of symmetry, x equals negative 4. Just a rough sketch, that's all we're doing. So number 2, y equals negative x squared plus 10x minus 23. So first we will find the axis of symmetry. I'll put the formula there. X equals negative b over 2a. Okay, so our b value for number 2 is 10. And 2 times our a value, which is negative 1. So that would be negative 10 over negative 2, which equals 5. So our axis of symmetry, x equals 5. And now we'll make our substitutions. And y equals, so we have negative 25 because 5 times 5 is 25, and then we have that negative in front. Be careful with that. So y equals 2. So the vertex is 5, 2. And so this will be a downward facing parabola because we have a negative value in front of our x. So that makes it downward facing. So draw it like this. And we'll draw the axis of symmetry. So the vertex is 5, 2, and our axis of symmetry, x equals 5. Okay, number 3, y equals 3x squared minus 12x plus 5. So first we need to find the axis of symmetry. Be careful with the negative sign. So x equals negative 12. Okay, we have negative 12 is our b value. Our a value is 3. Let's write that down. A equals 3, b equals negative 12. So negative 12 divided by 2 times 3 equals 12 over 6, which equals 2. So our axis of symmetry, x equals 2. Now we'll substitute 2 in the quadratic and evaluate. So this would be 2 times 2 is 4, so that would be 12 minus 24 plus 5. So y equals negative 7. So our vertex is 2, negative 7. So this is an upward facing parabola with a vertex at 2, negative 7, and the axis of symmetry, x equals 2. Okay, number 4. We have y equals 4x squared plus 8x minus 1. So let's identify our a value is 4 and our b value is 8. So first we'll find the axis of symmetry. So that would be negative 8 divided by 2 times 4, which would be negative 8 over 8, which equals negative 1. So the axis of symmetry, x equals negative 1. So let's evaluate for the vertex by substituting negative 1. So that would be 4. Negative 1 times negative 1 is 1, so that would be 4 minus 8 minus 1. So y would equal, so that should be a 1. Y would equal negative 5. So this is an upward facing parabola because a is positive with a vertex at negative 1, negative 5. And the axis of symmetry is x equals negative 1. Okay, let's change our color and move on to number 5. Our A value is -1, so this is a downward facing parabola. Our B value is -4. So x equals, first the axis of symmetry. Be careful with the negative signs. Negative times -4 over 2 times -4, which equals 4 over -2. I'm sorry, 2 times -1. Because this is a negative times a negative is a positive, so that would equal -2. So the axis of symmetry, x equals -2. Let's find the vertex. Be careful with the negative sign. Okay, -2 times -2 is a +4, but then we have that negative in front, so that makes that -4 plus 8, because we have that not again, -2, so y equals 2. So our vertex, -2, 2, and this is a downward facing parabola. Just a quick sketch. You can check these by putting them in Desmos. So the vertex is -2, 2, and the axis of symmetry is x equals -2. Number 6. I hope that you're not finding these too difficult. So number 6, y equals -3x squared minus 24x minus 42. Our a equals -3, so we have a downward facing parabola. Our b value is -24, so we want to be very careful when we evaluate for the axis of symmetry. So x equals negative times -24 divided by 2 times -3, which will give us +24 over -6, which equals -4. So our axis of symmetry, x equals -4. And let's evaluate for the vertex. Y equals -3. X is -4 squared minus 24, -4 minus 42. So that would give us -48, because that would be 16. -4 times -4 is 16 times -3 is 48. -4 in there. -24 times -4 is +96 minus 42. And when we combine all of those terms, we have simply 6. So our vertex is -4, 6. Again, this is a downward facing parabola with a vertex of -4, 6. And the axis of symmetry, x equals -4. So let's move on to number 7. Y equals -x squared plus 4x. There is no constant at the end. As you get further in algebra, we'll understand what that does to the graph on the Cartesian plane. But meanwhile, our a value is -1, and our b value is +4. So x equals 4 divided by 2 times -1, which equals 4 divided by -2. I forgot my negative sign. -4 divided by -2. Remember, it's x equals -b over 2 times a. So -4 divided by -2 is a +2. So my axis of symmetry, x equals 2. This is a downward facing parabola with a negative a value. Let's evaluate for the vertex. Y equals -2 squared plus 4, 2. So y equals negative 4. And the reason that's a negative 4 is because positive 2 times positive 2 is 4, and we're taking the negative, plus 4 times 2, which is 8. So y equals 4. So our vertex is 2, 4. And again, this is a downward facing parabola with the vertex at 2, 4, and the axis of symmetry at x equals 2. Number 8. We have y equals 8 squared minus 3. So we do not have a b, well, we have a b value, it's 0. Our a value is 1, our b value is 0. There's no linear x term in here. So we can think of it like this: x equals 0 divided by 2 times 1, which would equal 0 divided by 2, which equals 0. So the axis of symmetry is x equals 0. So the axis of symmetry is going to be the y-axis. Okay, let's evaluate for the vertex. Y equals, so we would have 0 squared minus 3, so y equals negative 3. So our vertex is 0, negative 3. And again, this is an upward facing parabola with the vertex at 0, negative 3, and the axis of symmetry at x equals 0, which will be the y-axis. And our last problem for today, we can see that it's downward facing because our a value is negative. So our a equals negative 2. Again, we do not have a b value, so our b value is 0 again. So let's find the axis of symmetry. We have negative 0 divided by 2 times negative 2, which would equal 0. Remember, 0 is neither positive nor negative, folks. Divided by negative 4, that equals 0. The axis of symmetry, again, x equals 0, but we have a downward facing parabola this time. We can evaluate for the vertex, so y equals negative 2. We substitute that 0. So y equals 8. So our vertex is 0, 8. And we'll sketch this as a downward facing parabola with an axis of symmetry of x equals 0 and a vertex of 0, 8. So that's it. Your homework today is right here. More of the same, of course. And let's go back to our exit ticket, which asks us how to find the axis of symmetry. We find the axis of symmetry with the formula x equals b, negative of b, divided by 2 times a. And that's how we find the axis of symmetry. So with the quadratic students, you really don't want to skip lessons and you don't want to skip homework. That extra practice is just going to drive it on home. These don't have to be hard. So if you're still rough on the factoring, get some extra help on that after school, or go back and review some of the lessons we've already done. But keep working hard because you know as you do, you'll be great. Good job.